acceleration. Let's see if we can get this in here. Acceleration. I don't want that in there. Acceleration is the change of velocity over time. Well, I'm working with my new bamboo here, so you have to, as I get a little used to this, you'll have to cut me a little slack on here. So the formula for acceleration is acceleration equals a change in velocity over time. And sometimes you'll see it written as final velocity minus initial velocity all over time. So we might as well take a look at maybe doing a problem here. One nice thing about velocity or acceleration when you start talking about automobiles and things, many times the initial velocity is going to equal 0, and we're going to use meters per second. Again, that could be different, different units and what have you on here. But when you start from a standstill or from beginning, the initial velocity is going to be 0. So let's look at a problem. Let's say, for instance, we got some Ferrari or some kind of car, and we're going from 0 meters per second to 60 meters per second, and we go, and it takes us about 2 seconds. So let's look at that, how we would end up doing that. All right, we know an acceleration equals final velocity minus initial velocity all over time. Well, if we take a look at this, we can start plugging in some numbers, and our final velocity is 60 meters per second minus our initial, and we went from a dead standstill, 0 meters per second, and it took us 2 seconds. So if we do the math here, 60 minus 0 is 60, divided by 2 is 30 meters per second. So what it's saying is we accelerated 30 meters per second every second. Quite often you're going to see this expressed as 30 meters per second squared. And I'll show you how we do this. This is really an improper fraction, so we have 30 meters per second all over a second, which is like saying a second over 1. And if you remember your mathematics, if you got an improper fraction, you can take this, invert, and multiply. So it's 30 meters per second times 1 over a second, and that ends up being 30 meters per second squared. So if you see that, that's what that's really saying, 30 meters per second, or 30 meters per second squared. Let's take another problem here with a little different units on here, and let's see if we can flip the page here. There we go. Alright, let's flip the page on this one. And let's say we've got an initial velocity of, we can go with initial velocity of 20 kilometers per hour. Initial velocity is 20 kilometers per hour. Our final velocity equals 40 kilometers per hour. And let's say this all took place in 2 seconds. Speaking of speed, hope you looked at my Twitter account. They're talking about the possibility of warp drive and how it relates to the Starship Enterprise, how that may be a possibility. So hopefully you take a look at my Twitter and read a little bit about that. Well, let's look at our formula. So acceleration equals final velocity minus initial velocity all over time. Well, again, this is a vector unit. When we talk about velocity, we're talking about a vector unit. It's a magnitude and direction. So we can plug this in. Our final velocity is 40 kilometers per hour minus our initial, which was 20 kilometers per hour. And this is all over 2 seconds. Well, if we end up doing the math, 40 minus 20 is 20 divided by 2 will be 10. So it's going to be 10 kilometers per hour per second. And what this is really saying is every second we went 10 kilometers per hour faster. Quite often you'll just see it written as 10 kilometers per hour per second. And that's that's an acceleration. For every second you're going 10 kilometers per hour faster. Well, sometimes you slow down, or if you come to a stop you put on the brakes. So let's take a look at a problem of that. And let's see here. So our velocity, final velocity, if you're going to stop, is going to be 0 meters per second. Our initial velocity, and let's just say for this one, it's going to be 30 meters per second. So we're slowing down. You're stepping on the brakes. Another term for this is deceleration. And let's just say again we come to a stop in 2 seconds. So same formula doesn't change. And acceleration equals final velocity minus initial velocity all over time. Sometimes you're going to see this written as a change in velocity over time. And that's really the same thing. Change in final velocity minus the initial. So let's go ahead and substitute in. Our final velocity is 0 meters per second. Initial was 30 meters per second. And it took us 2 seconds. Well, if we go ahead and do the math, 0 minus 30 is a negative 30 divided by 15 is a negative 15 meters per second per second. If you want to leave it in that form, that's fine. We went through the math earlier. That also can be written as a negative 15 meters per second squared. Well, when you see this negative velocity, what this really is, when you have negative acceleration, that really is deceleration. Deceleration. Acceleration. And that, when you decelerate, you are slowing down. You're coming to a stop. You're slowing down. You're not accelerating, you're decelerating. Something real quick on here, one other little note to make. Let's say you got a graph and you've got velocity on the y-axis and you got time on the x. If you have a straight line, this is constant. This is constant acceleration. We'll go over some of these problems in class, but hopefully this will help you out a little bit.